Hello, everyone, and welcome. My name is Liz Pimper, and I'll be your moderator for today's WJE webinar, Applying the Code to Existing Buildings. During the next hour, WJE architect Brian Tognetti and engineers Brian Calderone and Ross Smith will provide an overview of the existing building code evolution and summarize the application of today's IEBC provisions through a review of various project case studies with a focus on performing repairs. This presentation is copyrighted by West Janney Elstner Associates. And now I will turn it over to Brian Tognetti to get us started. Brian?
Thank you, Liz. Appreciate it. And welcome, everybody. Today's program is obviously its title, Applying the Code to Existing Buildings, and we're going to focus with an emphasis on repairs. So just real quick before we jump in, when we talk about the code, really what we're focusing on, since we only do have an hour, we're going to focus on the building code. Okay, there's lots of other codes. We're focusing on the building codes. When we're dealing with an existing building, what you're looking at in the picture there, that's a tornado-stricken school campus in the Midwest, the project I worked on a few years back. So you can kind of think things that go bump in the night. There's a lot of things that can happen to an existing building, and we need to apply the code. And so today's program, hopefully you can get some nuggets of information on proper application, proper enforcement, to just know that we're applying the code properly. So our learning objectives today, we're going to distinguish between those codes that apply to new building construction compared to existing buildings. And we're going to spend a little bit of time looking at the history of and the rationale behind those existing building code provisions. Why do we have them? Some folks might not realize they exist. We'll look a little bit at the repair versus the alteration provisions and really focus on the fundamental principles of repairs. And we'll walk you through a few case studies that we've worked on where we've applied various principles. So jumping right into it, when we talk about the code, what is it? What are we talking about? So the building codes for new buildings, they're there on your screen. We have the 2015 International Building Code and the 2015 International Residential Code shown. And usually, in different parts of the United States, different jurisdictions, may have one or both of these. You may have a different edition. They're updated every 3-year cycles. I'm showing the 2015 because that's what Michigan and a number of us in the Midwest are on. The most current one that could be adopted is the 2021. The 2024 code cycle is wrapping up, and those books will become available soon. And the 2027 cycle is actually about to begin. So when we talk about building codes for existing buildings, depending on where we are in the United States, it is also usually a book from the International Code Council, such as the International Existing Building Code, 2015 shown. Michigan is on that version. And each jurisdiction, whether at the local or state level, does make individual amendments to it. And we're going to focus on the IEBC as part of this program. But depending on where you're at, it might be Chapter 34 of the International Building Code or some version of Chapter 34. Chapter 34 is no longer in the Building Code, but some states do carry that forward. There's also, just so you know, there is an Appendix J in the Residential Code for those particular qualifying structures. And similarly, it's also a 3-year cycle, just like the Building Code. So why do we have these different regulations for new versus existing buildings? Well, there's really several reasons. 5 of them are shown right here. The first and foremost is to recognize the concept of lawfully existing conditions or grandfathering, right? It's reasonable, fair, and safe to maintain conditions that were once considered acceptable. In addition, historically, it has proven cost prohibitive to upgrade existing construction to new building code provisions. And we'll talk further on that, and mainly due to the unique challenges that are encountered as we work in existing buildings. Also, to remove regulatory ambiguity, you could envision if you're about to do a very large adaptive reuse project, and before even any of the funding is provided, folks really want to understand how is the code going to apply to this? What am I going to need to do? So that's a big reason. And also we want to establish reasonable upgrades proportional to the planned work. We'll dive a little bit deeper into that as we chug along here. Existing buildings need to comply with the codes and approvals under which they were built. That's the concept of lawfully in existence. And I've used that phrase. You will see that phrase in various code books beyond just the building code or the existing building code. You'll see it in the energy code or the fire code. You'll see reference to that phrase or a form of that phrase. Once a code provision has been formally adopted, it really becomes that benchmark of accessibility or acceptability. It establishes that line of sufficiency. What is sufficient? What is insufficient? It's a point in time that's accepted. And the concept of grandfathering is based on the idea that older construction, it's not bad. We just want new construction to be better. And there are exceptions to this rule. They are rare. But in different parts of the country, in different jurisdictions, you will find certain provisions written in that preclude continued use of certain things. So you need to be aware of that. So in code world, we can look at a couple things. So let's take a quick look at the intent provision of the 2015 International Building Code. Right at the beginning of the book, it says the purpose of this code is to establish the minimum requirements to provide a reasonable level of safety, public health, and general welfare through all the things that we need to do when we construct a brand new building. And if we compare and contrast that same section from the International Existing Building Code, you'll see some differences right off the bat. The intent of this code is to provide flexibility to permit the use of alternative approaches to achieve compliance with minimum requirements, to safeguard the public health, safety, and welfare insofar as they are affected by, and then all the things we can do to an existing building. So you can see right off the bat that this book is going to be different. There is going to be something different in a code world sense as to how the existing building code provisions are going to apply. One way to think of it is, and how I've thought of it, is on a spectrum of acceptable safety. If I am going to construct a brand new building and I'm going to use the International Building Code of my jurisdiction, I'm going to comply with the minimum requirements of that code, which is, the code does establish the minimum requirements. Then I'm going to come in maybe right at the midpoint of that spectrum. Maybe I'm a 5 on a scale of 1 to 10. If I'm going to produce a design that well exceeds the minimum requirements, but it's still a brand new building, right? It's exceeding the requirements, I would be a building that is higher on that scale, more safe. And by virtue of me having an existing building, a lawfully existing building, and I'm going to comply with one of the options that the International Existing Building Code provides, I'm going to come in somewhere lower on that spectrum of acceptable safety for that building and that project when compared to the same type of building if I were to do it or create it brand new today. The key is you're still on the spectrum of acceptable safety. So where did all this come from? Well, it really came from, it really started in the 1960s when Lyndon Johnson's administration wanted to understand better the causes of urban blight and why folks were leaving dense urban areas and choosing to construct new buildings out in the burbs. And so during that process, two significant impediments within the building codes. There were other reasons, but there were two code reasons. It's the 25-50% rule and the occupancy change rule. The 25-50% rule was a cost-based rule, and many of us remember those. You can actually look in those old code books and you can see them. Really, it was, hey, if you're touching more than 25% of the building, or your project costs more than 25%, you need to do so much code work. And if it exceeds 50%, then the entire building needs to comply. So you could imagine, and occupancy change was the same thing. The occupancy, the whole building had to comply. So it was very restrictive. And so right off the bat, that was one thing that from a national study, we felt we needed to change in the codes to encourage reuse of existing building stock. And moving into that 1980 range, you can actually look in the three model codes, the Uniform, BOCA, or the Southern Standard Building Code, and you can see the philosophy shift that occurred. And right off the bat, they removed cost from the equation. And they also introduced the concept of whatever you're doing in the existing building, do not make it less conforming. And they introduced the concept of upgrade only what you touch. So it's that Midas touch. Whatever you're touching, whatever's involved in your project, that needs to comply with code. And with some differences today, and we'll talk about we'll talk about that. It's fairly consistent today. There's a little bit differences with that third bullet. So moving forward through the 1980s, all the way up to the 1997 time frame, there was a document referred to as the NARP, Nationally Applicable Recommended Rehab Provisions. A national consensus document involved all three model codes, fire officials, building officials, contractors, insurance folks, building owners, and it was really the stage which established the current IEBC's work area compliance method. And some of those reasons why they felt they needed to do this, again in 1997, are stated right in the NARP itself. They had a couple good statements, and they say, while it is a relatively straightforward procedure to set out requirements for the design and construction of new buildings, the broad spectrum of activities falling under the general heading of rehab have proven more difficult to regulate in a rational, predictable manner. Building officials generally have wide discretion in determining the nature and extent of improvements required when buildings are rehabilitated or converted to new uses. And then owners and designers, even after reviewing the applicable codes, are correspondingly uncertain about what they can and cannot do. You want to with a couple more important points here. The provisions of the NARP are written to ensure that public health, safety, and welfare are maintained or enhanced as work is performed, and to require more upgrades to be included as more work is performed on a voluntary basis. It's a very important point. And lastly, they incorporate, that's the NARP they're referring to, incorporates the philosophy that improvements required when work is being done in existing buildings should be proportional to the nature and extent of the underlying work. So there's that rationale and the history. And also, in addition, the NARP recognized 6 specific types of work activities, and it applied a cascading philosophy of code upgrades. This diagram taken from the NARP compares the then model codes, the BOCA, UBC, and the SPC, and how it used to treat, for example, alterations in the middle. It was a very unknown, from an alteration, boy, you could be changing a little, you could be changing a lot. And you can see on the right-hand side is the NARP proposed approach. And interestingly, you can see there are now 3 different levels of an alteration. And that's where we get level 1, 2, and 3 of the alterations that you currently see in the IEBC. And it's very interesting. Almost word for word, the provisions are taken from the NARP into the work area method. So jumping to today's application, just a quick little cautionary note. Obviously, you need to check in with your jurisdiction, either at the state or the local level, on what specifically applies, if the IEBC even applies, and what addition is there. So for now, we're just talking generalities. So the IEBC uses the same cascading philosophy that we just talked about, and it uses the similar types of work in its application. And really, the concept is the more you change, and that's a very important word, change, existing conditions, the more upgrades that will be required. From repairs to alterations to changes of occupancy. Repairs, they're typically performed to maintain the integrity of something. So there's no substantial risk created since a previously accepted condition is being restored or otherwise maintained. Alterations, again, depending on the amount of change, a level 1, 2, or 3, we could be creating substantial risk that didn't exist before. So the code is going to treat it in a manner to address that risk. And obviously change of occupancy could be very significant, right? We could be creating a building where folks are now sleeping, where the building was never set up for that, or folks are not capable of self-preservation, and the building is not set up for that. So that's just kind of some of that philosophy. So that evolved existing code concept and where it came from the 1960s all the way to 1997 NARP, it does continue today in the current IEBC, but it's important. It's actually even more flexible than what it was back then. Within the IEBC, number 1, it's set up, do not make it less conforming, again, as we're relating to repairs, for example. And number 2, that Midas touch went away. You actually do not need to upgrade everything you touch. Instead, you only need to upgrade based on the type of work that you're conducting to or for that building, whether it's a repair project, an alteration, change of occupancy, etc. And since we're emphasizing repairs, there are actually two new thresholds. I shouldn't say new, they've been in the IEBC since the beginning, but there are two thresholds that did have to come into play because of this. And if it's a repair project, if the damage calculates to something referred to as substantial structural damage, SSD, there may be additional structural work you have to incorporate into your repair project. Same thing with a flood hazard. If your building is in a flood hazard area, there are specific terms defined in the code. There's substantial damage, substantial improvement. Okay, they are different and distinct from SSD, but nonetheless, you should be aware of them. The important thing is it doesn't, if you trigger one of those, it doesn't cause the project to not be a repair project anymore. It just may lead to additional work that you were not otherwise anticipating. So repairs versus alterations is something that comes across quite often, actually. And so we'll just touch on that for a little bit. What's the difference? Because, you know, an alteration level 1 to a repair can be very similar. Well, look at the definitions right in the IEBC, and there they are. Repair and alteration. So a repair is the reconstruction or renewal of any part of an existing building for the purpose of its maintenance or to correct damage. An alteration, conversely, is just any construction or renovation to an existing structure other than a repair or an addition. Well, you know, we can visualize what an addition is. A repair, you know, maybe not so, but you can see right off the bat that if something's going to be a repair or an alteration, it's going to be dictated by the definition of repair. So where did that definition really come from? Well, the IEBC's definition and intent of repair has been around for really a long, long time. I mean, almost 100 years now. So going back to the UBC's definition, 1927, Section 401, there it is, defined repair as means the reconstruction or renewal of any part of an existing building for the purpose of its maintenance, and which is almost word for word what is in the IEBC. Additionally, it went on to state the word repair or repairs shall not apply to any change of construction. So there's that intent. You cannot change things if it's a repair project. We really need to keep that in mind. Alterations is the same. The IEBC intent that alterations involve a change has also been around for that long. In the 1927 UBC, it defined alteration as alter or alteration means any change, addition, or modification in construction or occupancy. So you can see that concept of changing what used to be there is very significant, and it needs to be at our forefront to make sure we're applying the IEBC properly and that we're enforcing it properly. So repairing existing buildings in the IEBC, really, from a fundamental perspective, the IEBC's work area methods scoping requirements really explain it well. 502.1, repairs, and again, this is a 2015 edition. And repairs as defined in Chapter 2 include the patching or restoration or replacement of damaged materials, elements, equipment, or fixtures for the purpose of maintaining such components in good or sound condition with respect to existing loads or performance requirements. Doesn't mention anything about altering or changing or modifying, but you can patch, restore, replace, and the definition of repairs includes reconstruction, renewing, restoring. 502.2, application repairs shall comply with the provisions of Chapter 6 and related work on non-damaged components. So things that you might be touching that aren't even damaged, that is necessary for the required repair of damaged components shall be considered part of the repair and shall not be subject to the provisions of, and what's listed there are alterations, level 1, 2, 3, change of occupancy, additions. So, you know, Chapter 6 really lays out the groundwork for what a repair project is to entail. And something important to keep in mind, that there is no threshold on the cost, the extent, the size of a repair project. In fact, I mean, that's where we find the provisions for substantial structural damage. It is in the repair chapter. So in a nutshell, for most projects, the IEBC Chapter 6 repairs, if it's the 2015 edition, result in recreation of the conditions that existed prior to the damage, maintaining the level of protections, right? That's don't make it less conforming, and really no change to the fire protection, means of egress, accessibility, and energy provisions. Very little change, if any, to the MEP systems. Depending on the extent of work and what we're doing, those particular codes will have their own provisions, but from an IEBC perspective, it does not have additional work. And we just keep in mind that we might have more significant change to the structural aspects of our building if the damage triggers the SSD threshold. So there are a few fundamental principles we want to leave with before we pass along and look at some case studies. Number one, existing conditions are not unsafe simply because they do not comply with today's code, which is the new construction regulations. Number two, with few exceptions, new construction regulations are not retroactively applied to existing buildings. Number three, if something is not changed, no new risk is created. Number four, if something was considered acceptably safe just before the damaging event, why can't it be recreated to remain so after? It's a fair question. Number five, putting something back the same way is bringing it up to code. For example, if you are performing a project, whether it's an alteration or repair project, and you are complying with that jurisdiction's provisions that apply to existing buildings, you are bringing that up to code. And finally, when a building is damaged, with very few exceptions, the damaged parts can be reconstructed, renewed, or replaced in order to maintain the same use, purpose, configuration, and function that previously existed. And those highlighted words are taken right from the definition of repair and the scoping requirements. So with that, I will turn it over to Ross Smith.
Thanks, Brian. Just so everyone understands where we kind of sit locally, both Brian Tognetti and I are in the Midwest area. Brian Calderon is in Southeast United States in Florida. So we cover a little bit of different areas, and obviously we have attendees all from across the country. So if you have specifics about the code or certain applications there, we're happy to help you with that, or get some of our other colleagues in our other offices across the country to help. So what Brian just talked about is really important. The IEBC in particular is a tool we use in many situations. I deal with a lot of failure investigations and helping put things back together. And it is it's a great evolution that's happened, because we can use it to put things back the way that they were without having to upgrade things unnecessarily, as Brian discussed in detail. So we're gonna apply that and show this application through a few case studies, and then get into some of the nuances of how it's not so easy or not so simple every time, and just help you understand a few things you might want to think through as you apply it. So the first one is a snow-related collapse. This happened in the Midwest. It was in 2014. That winter in the Midwest, I grew up here, so I'm kind of used to snow, but it usually comes and goes and comes and goes. So it'll snow a bit and then melt off, and snow a bit and then melt off. And in this case, this season, the snow came and it stayed, and more came and more stayed, and it kept going and going and going. And we had a long winter of lots of collapses, both of old buildings that have just been overwhelmed and newer construction that just wasn't ready for it either. In this case, it was a very large industrial, kind of heavy duty construction. It had been a furniture manufacturer. This was actually the second floor of this large building, but robust construction materials, steel decks, steel columns, joist girders, all steel. And in this case, as you may suspect, the overwhelmed, the internal roof drains were just overwhelmed, whether there was debris in them or ice or whatever. And that continuing accumulation of snow caused this fairly localized collapse. 2 bays went down entirely, as you can see in the photo. The rest of the building was generally undamaged, so it was very interesting how localized things were. So if we zoom in on this a little bit, you can see on the left, the joist is down, several of the joists are down, the joist girders are damaged, the deck is down, and you can see snow and daylight kind of in the background underneath the structure. You even see the gravel of the ballast from the roof that had just kind of fallen into the building. On the right, in addition to the joists that we see down, this is a joist girder, so a secondary member that's supporting some of the initial members. So pretty significant structure down, but also note that on the one side it's very damaged, and on the other side it's pretty much untouched, so very localized, as we mentioned. You can see again here, this column is bent over. That that doesn't happen a lot unless you have a very large and very sudden change in load or in how the load is being handled. So we see lots of damage. You don't often see a column folded over in half like that. And then again on the right, a little bit more of the debris field from the event, very similar to some of the first photos we looked at. So can we repair this? Absolutely. And in this case, because of the isolation of the event, and it stayed in just a couple of bays, we're really going to just repair, or in this case, pretty much just replace those 2 bays and get things back going in the order that they were before. What's nice here in this one, kind of a clean getaway here, is there weren't a lot of repairs to the surrounding elements other than the ones that had collapsed. The rest of the columns, the rest of the joist girders and joists really fared very, very well. So it was going to be a pretty easy, relatively speaking, easy repair process. I think it's important, though, to touch on something Brian mentioned a little bit in one of his slides, and that relates to substantial structural damage. So I'll refer to it as SSD. SSD is very important in any damaged property situation, but it doesn't always mean intuitively what you think it does. SSD is very specific in the code to achieve that status, so to speak. There needs to be damage to the vertical gravity load-carrying elements or the vertical lateral load-carrying elements. If we boil that all down, that means columns and walls, vertical elements of your building. So where it can be non-intuitive is you can have a significant amount of damage to a roof structure, which is horizontal framing, or some other parts of your structure, and not to the columns or the walls, and you will not have sustained SSD. It does not mean that there isn't a lot of damage. So if you have an engineer like me or an insurance adjuster or someone on your site after an event, and you hear them saying something like, well, this isn't substantially damaged, there hasn't sustained substantial structural damage, that doesn't mean this isn't a big deal. It doesn't mean there's not a lot of work to do and that there's heartache. It means something very specific from within the code. It is something we consider on almost every collapse and almost every damage project. So in this case of the 2-bay collapse from snow, we did look at that, and we reviewed SSD and actually looked at it from a couple of different perspectives because the code official had a slightly different view of how we might want to look at it. And what I mean by that is local versus global. So if you look at those 2 bays and several of the columns were broken, one was folded in half, then if you look at just those bays, that locally you've achieved SSD. But if you look at it globally for the whole floor or the whole building, we certainly have not, just because it's a very, very large building and a large number of columns, and percentage-wise, really very little of it had been damaged. But the key point there is it depends on the perspective that you're looking at, and engaging with a code official early in your assessment and what you're planning to do is important. We did this probably midway through on this repair design and didn't have a lot of trouble and worked through a couple of kinks with the official, but always encourage engaging with the official. Make sure you have the same understanding of things as they do when you get things back together. Yes, there have been a few instances where we don't agree with the building official or they're not even aware of the existing building code, but generally they know things pretty well, and it's good to get aligned with them and avoid confrontations or any problems later. So get them involved early in the conversation. So getting back to the repair, you can see once we kind of cleared away the debris field, it was just like we mentioned, just 2 open bays that needed to be put back, and the rest of the structure had fared quite well. That's on the left. On the right, we're installing that new steel and the new joists. Still haven't been painted, so they look a little bit darker than the underside of the rest of the building, but a pretty clean, easy application of IEBC. So, as I said, just to summarize, it's a simple application of that. We're allowed to put it back the way that it was. And a couple of takeaways from this case study is repairs can be straightforward, and we definitely want to confer with the building official early to avoid any surprises and make sure we're on the same page. This next case study is a fire loss that occurred at a stadium, and in this one we had to look at various different codes, and there are a few complications which we'll get into. So this event coincidentally was around 2014 as well. Although there's snow covering the debris field, it was not snow related. Happened to be that same cold winter, but it was a fire related event. Interestingly, although it's a stadium, it is primarily residential type construction. So that was a little bit surprising to me when we did the investigation. While there was some structural framing and some CMU walls and so forth, a lot of the structures were made out of wood. So wood decking, wood wall framing, metal plate connected wood trusses, a lot of stuff that you would see in a residence. Doesn't make it wrong, it just was a little bit surprising to me. And in this case, unfortunately, the suspected cause of the event was a space heater being used by some service contractors in the winter. I don't recall if it was over lunch or overnight, but in any case, it was on and it led to a fire. And it was a pretty substantial fire. I remember it being on the news. I remember, all the live cameras watching it happen, and it took a while, but they did get it. They did get it out and saved some of the structure. And you can see kind of the aftermath here. So this is from the outfield looking back towards about home plate. So on the left-hand side is basically the first baseline, and all of the structure that was there was gone and damaged. This is a closer view of the same kind of transition from where the damage occurred to where it stopped. And a couple of interesting points here. Number one, it was an interesting view from within the truss space that I took the photo on the right. You can see a lot of charring, some collapse because of some of the understructure that had failed. But also right behind me, which can't be seen in the photo, is the fire barrier, the smoke barrier within the trusses. And what it was astounding to me is how well it had performed, both here and at the lower levels. You could walk along in the hallways, the finishes were intact, and then suddenly you open a door into this void. So the smoke and fire partitions within the building really did their job very well and helped keep this somewhat localized, that and the great efforts of the firefighting team that allowed them to save some of the building. So looking around at the rest of it, you can see, even though this is exposed because of some other damage, this truss on the left just has a little bit of smoke staining, nothing structurally concerning. And then the column on the right, there's some paint failures from the flame, but wasn't hot enough to displace the steel or anything like that. So all in all, we're expecting to be able to put things back the way that they were. So our intentions are repair, as we've been talking about today. So we're going to rebuild and repair the first baseline structures, replace some of the other auxiliary structures that were destroyed in the process. And there was one more pressure point. We had a big meeting with the owners of the ball club and all the insurance adjusters and all the designers and the contractors and so forth. And the owner came in, thanked us all for being there, thanked us all for being responsive, and said, we are hosting the all-star game of this league in July. We're still doing that. I expect that we're going to be ready for it. That was a lot of pressure on the whole team, and a pretty ambitious goal considering the state that things looked in January after this fire. So again, looking at the code considerations, we expected, all right, we'll be able to put things back the way that they were. 2009 was the code at the time. But as we started peeling back the layers on a few of the components of the building, we realized that some things weren't quite right. Primarily, some of the CMU walls on the auxiliary structures weren't up to what they should have been when they were built. So we had to look back at BOCA 93, which was their original design, and then start looking at the new codes as well. And why we had to do that, it goes back to what Brian focused on a couple of times, where he says, was it lawfully in existence? Well, if the walls weren't built or reinforced to the code at the time that they were constructed, well, then they weren't lawfully in existence. So even though they were providing decent service and hadn't failed, they weren't right from the get-go. So when we go on and put things back the way that they were, well, they have to be lawfully in existence to put them back that way. Because they weren't, that means we need to rewind a little bit and get them back to where they should be. So in that case, we needed to change things a little bit and improve them because they weren't right in the first place. Another interesting wrinkle on this project was we got asked to look at the fire suppression system, primarily the hydrants. And we went through a pretty detailed review of capacity and what they had and what they needed. And it did turn out that we felt their capacity was sufficient. They didn't need other hydrants or so forth. But the building official, because of the large concerns of the building and the fact that there's large gatherings there, they felt a little bit differently, and they were pressing to require some upgrades. The point of that is it's important to understand that this clause exists in these codes that we're talking about. It talks about the code official having the authority to render interpretations. That's their job. They can and should render interpretations, and they may clarify things a little bit differently than what we do. So even though we may not always agree, they usually have a good intention in mind, and we need to work with them on that. Could you go toe to toe and fight them and pursue litigation? Sure, you could do that, but that's usually not going to be a path that is a very clean or recommended path. And in this case, I felt the owner made a very good decision. He said, "Look, this is a community. I need to work with this official. They've been great to me over these years, and we want to continue that relationship. So if they think we need to make these upgrades, we're gonna go ahead and do that, because we want to keep things above board and keep everybody safe and move forward." And I thought that was a great decision. And it's just important to understand code officials do have some rights there, and it's in the code what their authority is and what they can do. So wrapping this one up, amazingly, the construction team and the design team got this back together and got it back in place. They hosted the All-Star game that July without much fanfare. It was no problem. So kudos to a great collection of individuals that made that happen. So let's summarize this one. Again, some conditions were nullified. We couldn't use the IEBC because we had some things that weren't lawfully pre-existing. And it's also important to recognize that even though some things might not have made the cut, that doesn't mean all. So just because the CMU on a few walls wasn't up to snuff, it doesn't mean we now have to upgrade the entire building. You can localize those components. Again, the takeaway here, we touched on it a few times. The IEBC, using it does hinge on lawful preexistence. And if you don't have that, then you're going to have to rewind a little bit and make sure you understand what should have been there. And also, the code official's interpretation holds a lot of weight, regardless of what you feel as an owner or what as an engineer you may disagree. Their opinion matters. And again, as I said, engaging with them early and getting aligned with how you're going to interpret things and how you're going to redesign things is usually best for the process and all the parties involved. The last case study is a little bit of a departure from some of the things we've been talking about. There are repairs implied here, perhaps, but it's a little bit more about adjoining development, still existing buildings, and Chapter 33 of the building code. And you'll understand where we're going in just a minute. So this is an example of a new development at an abutting building. So there's these two, we call them twin buildings in the middle of a downtown area. This is actually in Philadelphia, I believe. And you can see they're slightly different, and let's explore the nuances of that. On the left-hand side, you've got square top windows. The right-hand side, the arch top windows, and the entrances are a little bit different, and the landscaping is a little bit different from one to the other. But for all intents and purposes, they're very similar. Well, one owner on one side was intending to make some changes, and when you do that, there are some repercussions on how it affects the other building. So I want you to look closely and see if you can notice, there's some changes here already, but see if you can tell the difference between what they started with here and then what they ended with here. Obviously, a pretty large alteration or change here, and while they're allowed to do that, there are repercussions that come with it that we need to understand. So the building code does address these things. They do it in a couple of different ways, and we're going to walk through those right now. Just looking at this from a different perspective, the picture on the left is the same. The picture on the right is the view from the back of the new 3-story structure, looking at the back of the original 2-story structure. And you can see it's very exposed, and there's kind of a debris field there, and lots of things which we'll get into in just a moment. So generally speaking, Chapter 33 of the building code deals with this existing building by saying this is how you have to protect it. And I'm not going to read the whole thing to you, but let me highlight a couple of spots. Generally, protection needs to include dealing with footings, controlling water runoff, giving notice to your neighbor. These are the main things. So if we summarize those, we'll repeat them a little bit here. Again, it's from chapter 33. You need to protect the foundations or the footings. You have to deal with the water runoff. This includes snow. So if we're going to build a big, tall tower next to a previously existing building, now you're creating a snow drift situation that may not have been there before. You also need to notify those neighbors in the city and give them those 10 days at least. You can just sum that up to do no harm to your neighbor's building and account for whatever changes you may be imposing on them, whether they want it or not. So locally, these amendments can get extended. And in the city of Philadelphia and many other places around the country, they do get extended. So we won't go through all the details of that either, but realize that some places it's just that one paragraph I showed you. Others, it's a couple more paragraphs. In this case, it's pages and pages of requirements. So you can see the keys that we're touching on, though, is the soil and foundation work, a pre-construction survey, underpinning, support of party walls, protection of roofs, interior walls getting exposed, and so forth. And how does that apply here? Well, on the left-hand side, you've got an interface between the existing buildings. How do we waterproof that? You've got an existing low roof that's now got water shedding onto it that wasn't there before, got snow going onto it that wasn't there before. And again, things down to foundation. On the right-hand side, we now have what was an interior wall turning into an exterior wall, and it's not insulated, it's not waterproofed. How do we handle that? Well, the code has requirements for that. And again, the foundation in the lower right-hand corner is going to be impacted as well. So summarizing this case study, the IBC covers how we deal with neighboring existing buildings and abutting and adjacent buildings. There may be local amendments. Make sure you understand that so that you are complying with all of them. The takeaway here is it can be a significant impact that you and your development are having on other people that can fundamentally change almost everything about the building. So make sure we're being mindful of our neighbors and make sure if you're the one being impacted, you understand your rights and what the code requires. And with that, I'll hand it over to Brian Calderon to give us an example about repairs in flood hazard areas.
Yeah, thanks, Ross. So as Ross had mentioned, I'm down here in our South Florida office, and one of the things that we've been dealing with in Florida since the fall is some of the unfortunate after effects of Hurricane Ian, which was a significant storm surge and flooding event in some parts of the west coast of Florida. So I wanted to talk a little bit about something that's a touch different, and that's dealing with repairs in flood hazard areas. And so in flood hazard areas, the existing building code has a provision that says, hey, if you've got a structure that sustains substantial damage, then it needs to be brought into compliance with Section 1612, or basically the structural design provisions for flooding for new construction. And then it goes on to define what substantial damage is, and actually has an exact same definition for something known as substantial improvement, so it's not always just damage. And it's for the purpose of determining compliance with this, it's if your building's damage has exceeded 50% of the cost of the market value. So if the cost to repair the damaged condition exceeds 50% of the cost of the market value. And one thing that maybe is worth noting, this provision applies to any building located in a flood hazard area, which is defined as a location with 1% or greater chance of flooding in a given year. And knowing if you're in a flood hazard area or not is something that FEMA establishes maps for, and your local jurisdiction will adopt certain versions of certain FEMA maps as the FEMA maps are updated. So you have to kind of take a look at your local compliance to know which flood map they've adopted, and then whether or not the subject property that you're dealing with is in a flood zone. And again, one thing to note about the damage is these conditions don't have to be damage due to flood. It can be damage due to any event. It can be damage due to wind, damage due to a fire, damage due to a car impact or other. And then these provisions apply just simply based on the location of your building. Okay, so I've got to meet the structural design provisions for flooding for new construction. If I hit this threshold, well, what are those provisions? Well, one of the things that comes into play is, well, what flood zone are you in? And so I'm going to play a little video put on from FEMA that talks about some of the differences of requirements based on what flood provision or flood zone you are in.
There are 3 basic coastal zones and 1 new zone in the new NFIP maps. The flood zone X is considered to be a low risk of flooding. VE zones, or coastal high hazard areas, are zones where high velocity wave action accompanies the storm surge and can cause severe damage to buildings. AE zones are areas affected by storm surge, but where wave action is diminished or absent. For the first time, FEMA has established another area within the AE zone called the Limit of Moderate Wave Action, or LIMWA. These moderate waves can cause damage to buildings, though they are not as damaging as the waves expected in the VE zone. Communities that adopt the Limit of Moderate Wave Action as a higher regulatory standard may earn flood insurance rate discounts.
All right, okay, so maybe as sort of foreshadowed by that video, right, depending on what the state of your existing structure was, many cases, those flood provisions require modifications that are substantial, significant changes, significant improvements to deal with these higher base flood elevations, to deal with the effects of surge, to deal with the effects of wave action, depending on where your structure is. And certainly these apply to all areas of flood zones, even inland ones on inland bodies of water, if it's designated as a flood zone or a river, things like that. And so triggering the substantial damage component of the flood zone provisions of the code is a big deal, and identifying whether or not all of that extra work is going to be required it all circles on this definition of substantial damage. Now, the code is not the most helpful as far as providing answers to the substantial damage, and part of that's because the origins of this are a little bit more driven by the flood insurance provisions of the National Flood Insurance Program. And so to get more specific answers on triggering this upgrade or this threshold, key definitions are found in some documents put out by FEMA, at least the minimum requirements. And keeping in mind that the local communities that you're in and their enrollment of the National Flood Insurance Program, they may and sometimes often adopt more stringent requirements, most often consisting of a lower threshold, 25%, 30%, 40%, and they're incentivized to do so as they get different improved premiums on their flood insurance program by adopting more stringent compliance provisions. So knowing exactly where the trigger falls and some of those specific requirements is a local dive, but the minimum ones put on by FEMA are some of the ones we're going to talk about here moving forward. And so, okay, the 2 questions are, how do you define market value, and what's included in that cost to prepare? So taking a look at market value, right? So what is market value? Well, it's essentially the price that a seller of the property can expect to receive from a buyer in a fair and open condition. Okay, well, it's still sort of complicated, but one of the things that is focused on there is the market value is limited to the structure, the subject building, right? It's not including the value of your land or improvements on the land. So if you've got swimming pools or great pavements or patio, it's just the building that is being evaluated for the substantial damage threshold. And so that's the part that's being considered. And just since we've kind of been talking at you here for nearly 50 minutes, this photo we just took here on Sanibel over the last month, you got to imagine being in this building during storm surge, storm surge getting into the second story of this building here. It tears down the sliding glass doors. It completely guts this building. It fails the precast hollow core plank, right? And sitting up there, just perched like nothing ever happened on the second story of this building that is also missing its doors and wind and waves crashing in it, just delicately little balanced wine glasses. So it's certainly always interesting to say not everything is probably damaged in this building despite the significance of the event. But okay, back to market value, right? Okay, well, how do you determine that more accurately? Well, some of the things that we've seen most often, and I think what's most often used at determining market value or or either actual cash value, which is the cost to replace the structure, and the value of that minus depreciation for age, use, and neglect, or maybe what I think I've seen the most often, which is the replacement cost value. So what would it cost to rebuild the same property at the same location today with the current present cost of labor? And so using those as the general guidelines for market value is what we've seen most frequently. On the repair side, okay, so what's included in the cost of repairs? Right? Well, it's really the cost to bring the building back to its pre-damaged condition. So it's not the cost to improve the side pavements or everything that might be needed in that property. It's what does it take to get it back to its pre-damaged condition. And actually, some of that may be a little bit easier to think about what's excluded, right? So some of the things that are excluded are the cleanup of trash, the cost to stabilize the structure, any of the engineering or architectural or survey stuff, both to assess your building, to understand what needs to be done, as well as the cost to design the repairs or design any of that work. So that's not included in the repair cost. Permitting fees, things like, again, the outside improvements, which I just touched on, or any of the appliances. But otherwise, it does basically take you getting back to the condition of your building in its entirety. That's finishes, that's the electrical, that's mechanical systems, roofing, anything that was damaged on the building that needs to get back to it, that's included in the cost of repairs. So what can engineers do to help? Well, I think in the case of these flood provisions and I guess making sure whether or not you trigger the substantial damage requirements, the best ways that engineers get involved to help these are conditions where identifying exactly what needs to be addressed, understanding what really is damaged and what's really not damaged, not being conservative and replacing things or that can be repaired, kind of sharpening the engineering pencil. These are places where that can provide significant benefit. For if we get past that 50% value number, right, then we're triggering to the much more substantial improvements or stringent requirements for new design. All right, so we talked a lot. What are the main takeaways here? Well, there's a few, right? And one of them is, and I guess maybe the one that Brian hit most eloquently, is in the code world, existing buildings, they're different. And the code offers much relief compared to those established for new building code provisions. As long as you have the lawful existing conditions, you'll likely have some options, some flexibility for preparing repairs. In most situations, with the few of the examples that exclusions we talked about, there shouldn't be too many upgrades required. Put it back the way you found it. To achieve proper application and enforcement, knowing the minimum code requirements is key. But it's confusing. There are folks out there that can help and answer many of the questions they may have. So with that, I want to thank you all for attending, and we'll kick it back to Liz to deal with questions.
All right. Thank you, Brian. That was a great presentation, and as you said, a ton of information. So we have run a couple minutes longer than we intended to, so we will take questions for a couple minutes past the hour just to fit in some of these. There's a lot of really good ones coming in. Okay, our first question is really a couple questions that have come in, all related to how the IEBC applies to historic buildings, if there's greater flexibility or different requirements. One of you could speak to that.
Yeah, Liz, this is Brian. I can speak to that. Yes, if you do have a qualifying historic structure on a state, local, or national registry, you do have additional flexibility, and they are treated differently. You have additional alternative approaches to how you treat things. So even more relief, and that would be my answer.
Yeah, and even in the flood provisions that we just talked about, there's even carve-outs for historic structures, typically not needing to deal with the substantial damage requirements.
Okay, our next question. How is the IEBC used when the scope for one project includes repairs, alterations, and additions?
I'll jump on that one, guys. So within the IEBC, there are multiple options you can use, either the prescriptive, performance, or the work area method. And so depending on what you're including in your project, you could have repairs, alterations, changes of occupancies, all within the same project, all using the work area compliance method, or all using the prescriptive method. Within those chapters of the book, it will tell you what you need to do in those parts of the building based on the type of the work that you're doing in that part of the building. That's something that's easily missed.
Okay, our next question. Do you foresee the IEBC changing the overall concept of, quote, it was safe before, then it can be rebuilt and still be safe due to climate change?
I'll just jump on that for a minute. Not for climate change purposes, I guess, would be my perspective on it. I would take more of an energy twist to that. And when we deal with energy, and just like all the other, there are many other codes besides the IEBC, we first see energy come into the IEBC when we're dealing with an alteration level 1. So energy isn't, there's no improvement to energy in a repair project. However, obviously we can see movement changing in the future here. So I wouldn't be surprised if we see some movement changing in the energy codes, and we'll see if it makes its way into the IEBC in a different manner. It's an interesting question.
Well, I'll take it from the stance that if by climate change we're thinking about perhaps more extreme weather events, for example, hurricanes or otherwise, and in that sense, not that we know exactly how the codes are going to evolve, but historically, there's no precedent for that. As we've increased design requirements in some cases for higher wind speeds or different provisions for snow loads, for example, even things with drift, even seismic requirements where we understand we've got vulnerable details. It's not been practiced that you have to retroactively deal with many of those. And so if that is something that changes, it would be something that's new that we've not done from a code standpoint previously. Substantially previously.
All right, our next question. Is there a general rule of thumb, excuse me, is there a general rule of thumb on how much structural modifications trigger bringing the entire building to a current structural design code for a remodel type project?
I'll jump on that a little bit first, and Ross or Brian, you can chime in. But in general, no, there is not. Again, it refers back to the type of work you are doing and the intent of your project. If it is a repair project, there are certain structural requirements. If you are altering, if you're, let's say, when you use that word remodel, that's why it's important for our terms. I'm envisioning some form of change. And so depending on the amount of change, you're either going to be a level 1, level 2, level 3, and the structural requirements will be different for each of those levels.
It's also important to understand how the use of that building may have changed. If it has slowly evolved over time from one use that it was originally designed for into some different use, that can be troublesome, right? We've had many situations, and there was another question that says, do any of these classifications affect an insurance claim? Those types of small, slow evolving changes can catch up with you when you get into what you think is a repair. You go to put it back the way that you thought it always was, but you're using the structure much differently, you're occupying it differently, and you really haven't kept up with the codes. So I think the original question you asked, or you answered, Brian, was about, is there a rule of thumb? And I agree, there's not, but there are lots of things to consider, especially in an insurance situation or in a large repair situation of, yes, we can put it back the way that it was, but is the way you're using it the way that it was? Sometimes that has evolved without you really realizing it.
Well, and one last piece I do want to say, there is a 5% criteria, or an overstress of 5% recognized in an alteration level 2 structurally before there's some additional work that needs to be completed, just so folks are aware of that as well.
Okay, our next question. If a building was permitted, inspected, and certified for occupancy, is it not by default in lawful existence? What triggers the need for forensic analysis?
Well, I'll take a stab at that one. I generally agree with that statement, and most folks do agree with that statement. Again, it's the codes that were in effect, if there were any codes in effect, right? We have some very old buildings that didn't have any codes applicable, but there's also just the approval. So it's the codes and approvals and the uses that have been allowed, and obviously a discussion and agreement among the interested folks of that project. But yes, in general, I agree with that.
It's also important to consider whether it makes sense. The purpose of these codes is to try to be logical, as Brian touched on early in his presentation. If the building was fine yesterday and it's been serving fine for a long time, why does it being damaged today from a fire or a wind event or something out of the ordinary, why does it make it not safe anymore? And that's why we like to put things back the way that they are. However, there are other things where we've learned that it might not be the best idea to do that. If you could have left it alone, but you now know there is a large new drift that wasn't accounted for in the original design, you might want to just account for that. It might make some sense. It might ethically make sense and logically make sense, even though the code may not require it. So these are the minimum existing requirements. Sometimes there are situations where we say you don't have to do this, but we recommend that you do.
And just one last piece on that. It's really important to know, just because the building may be lawful doesn't mean every component constructed in that building is lawfully in existence. So just because you may have some conditions within the building that are not lawful doesn't now make the entire building ineligible for the IEBC. So those components need to be addressed separately. And interestingly, the IEBC does not require someone to go back and assess that. However, the building official absolutely has that right to ask for anything they want in terms of assessing the legitimacy of an existing building. And I'm glad it does that.
And it's not that we're necessarily loophole hunting, right? I mean, all of this comes back to provisions of, hey, if it was safe enough on that threshold of safety, which is not a black and white switch, right? Are we making sure that something that we as society or we in this environment or community have accepted as safe enough because it met some code requirements at some point, then why should we retroactively say what was safe yesterday is no longer safe today if nothing's changed other than putting it back? So.
All right, that is a great place to wrap up. Thank you, Brian and Ross and Brian. That was a fantastic presentation. And thank you all for joining us. We hope it was educational. If you have any questions about the presentation today, please don't hesitate to reach out to any of the presenters. And if you have any questions about WJE webinars, please reach out to me, Liz Pemper, at lpemper@wje.com. So again, thank you so much for your time, and we hope you have a great rest of the day.